Hey guys, welcome to another maths tutorial by the Magic Monk. Today we're going to show you guys the proof of the product rule. So if you remember the product rule, basically it's if y is equal to the product of two functions, for example, if y equals u times v. So I know that before in the last tutorial we did f times g, but u times v is same thing. If y equals u times v, where u is equal to a function of x and v is equal to g of x. Alright, so what's going to happen now is if we let x increase by delta x. Let x increase by delta x. Let x increase by delta x. So x has increased a little bit in both of these functions. So what does that mean? That means u will increase a little bit, v will increase a little bit, and y will increase a little bit. So what does that become? Well, that becomes y plus delta y equals u plus delta u times v plus delta v. Right, because a change in x will increase v, right, or increase or decrease or whatever it is, but basically there's a change in v and there's going to be a change in u, and there's going to be a change in y. So this could be increase or decrease. Basically it means the value has changed. Okay, so now let's rearrange this equation. Let's move y to the other side. So this becomes u plus change in u bracket v plus change in v minus y, because we have just moved y to the other side. Now if you look at the previous definition, y is equal to uv. So instead of saying y here, I'm going to say uv. Change in y equals u plus change in u times v plus change in v minus uv. Okay, now I'm going to very carefully expand these brackets. So now I have change in y equals uv plus u change in v plus change in u times v plus change in u times change in v minus uv at the end. Okay, so now let's cross out the terms that are cancelling each other out to 0. So uv minus uv cancels each other out to 0. So what we have is change in y is equal to u times change in v plus v times change in u plus change in u times change in v. So far it still doesn't look like the product rule. So I'll just show you guys the final product rule. The product rule was if if y equals u times v, y dash equals u times v dash plus v times u dash. So it's starting to look like that. But basically we want to have change in x at the bottom here, so eventually becomes delta y over delta dy over dx, and we don't want this change in u, change in v on the right. So just so you know where we're going with this. So well, let's start by putting changing y. Let's start working from here again. So I'm gonna put change in x on the bottom of both sides. So it's gonna be u change in v plus v change in u plus change in u change in v over change in x. Okay, so now we have one fraction on the right with the same denominator, which means we can separate it into three fractions. So we have u change in v over change in x plus v change in u over change in x plus change in u change in v over change in x. Okay, now we're going to take the limit of both sides as change in x equals 0. So limit as change in x approaches 0 of changing y over change in x equals limit as change in x approaches 0 of basically copy this again. So I'm going to copy this instead of writing it all out. It's not letting me copy. Hang on a second. Not letting me copy. I'll write it all out again then. So we got u change in v over change in x plus v change in u over change in x plus change in u change in v over change in x. Great. Okay, now if you apply one of the limit laws, we can separate the sum of terms in a limit into the sum of limits. So then, well, this part here can be simplified into dy over dx, as you guys know. And then on the right hand side, I have limit as x approaches 0 of u change in v over change in x plus limit as x approaches 0 of v times change in u over change in x plus limit as x approaches 0 of change in u change in v over change in x. Okay, so using another limit law, what you would know is be able to do is, if there is a coefficient of a limit, you can actually move it to the front and it'll still work. Alright, so rather than showing you an example of that now, I'll get you guys to just prove that yourself. But basically here we can convert that to dy over dx equals u times limit as x change in x approaches 0 of change in v over change in x plus v limit change in x approaches 0 of change in u over change in v plus the limit as x approaches 0 of change in u change in v over change in x. Okay, now what we're going to do is we're going to simplify where we can, and this part here limit as x approaches 0 of change in v over change in x can now be written as u times dv over dx plus v times here, this part here can now be simplified into du over dx, which is very similar to the product rule which we have here. In fact, it's exactly the same. So now we just want to work out how to get rid of this, right? Because we don't need anything here. Now let's have a look at this closely. So we have the limit as x approaches 0 of change in u times change in v over change in x. Okay, so how do we deal with that? Firstly, I just spotted a small mistake. This part here, this should say change in x. Alright, not change in u. It should say not change in v, it should say change in x. So there, it fixes that. Now, how does this part equal to 0? Now, I'm just going to multiply both the top and the bottom here by change in x and see what happens to that. So I'm just going to move this to the right. We're just going to work on this bit here now just to show you that it's equal to 0. So limit as change in x approaches 0 of change in u, change in v over change in x. Now I'm going to multiply both the top and the bottom by change in x, which you're allowed to do with a fraction. So now it becomes now what we can do is we can turn this into the product of three terms. So we have limit as change in x approaches 0 of change in u over change in x times limit as x approaches 0 of change in v over change in x times limit as x approaches 0 of change in x. And what do we realize? Well, this part here is du over dx. This part here is dv over dx. And this part here is equal to 0, right? Because limit of change in x as x approaches 0 is going to be 0. So that means anything times by 0 is 0. So this whole thing here is 0. So going back to our equation, we've just proven that dy over dx is equal to u times dv over dx plus v times du over dx. Okay, hope you guys understand what I have done here. You shouldn't need to memorize this for your high school maths exam, but it's helpful to show you guys how the product rule was developed. Okay, see you guys.